Hello everyone, you are all doing well. In today's class, I am going to cover a few of the remaining concepts present in the second unit as follows. If you observe, the contents present in the second unit are storing documents, detecting duplicates, and removing noise. As part of the storing documents, we are going to understand what is the need of storing the documents in the web. So we know that web is a huge collection of the documents. Whenever you perform any search operation, if you are able to retrieve any information from the web, how you are able to retrieve the information, you have to think here that whenever there is a copy of information or the documents available on the web, then only you are able to retrieve any particular information about what you are searching for. So that's why what is the necessity of storing documents and how we are storing the documents, and we are going to know what is Google company is going to use for storing the documents. And as part of the detecting duplicates, as we know that what is detecting duplicate? Duplicate means so repeating the same documents. So whenever you see the web consisting of a huge collection of the documents, in the huge collection of the documents, the same document may be replicated somewhere, the same information may be repeated somewhere. Whenever the crawler is going to identify the documents, it has a burden on it. It has the burden on it. How we are going to detect the duplicates in the web and how we are going to reduce the burden for the search engine, we are going to know about it. And as part of the removing the noise, whenever you see there are very popular web pages and websites are maintaining, and along with them there may be some of the websites which are used to mislead the people. They will also maintain the information in those websites. Here how a web page consisting of the text, for example, if you see the web page, in the entire web page only the portion of the data is only the content, and remaining portion is all about the unnecessary information about the particular document. Here you try to understand, whenever you are trying to retrieve particular information about any topic, at initial time if you able to retrieve one particular document, the document consisting of the entire textual information, in the entire text only the few of the portion of the text is useful for the retrievaling of your information, but the remaining is unnecessary and unrelated information for the web search query. That's what we are calling it as a noise, and this is what how you are going to identify the noise and how you are going to remove the noise. So these are the concepts we are going to learn as part of the storing the documents. As part of the storing the documents, what we are going to understand here, after documents have been converted to some common format. So this is what where we studied about in the previous class in the conversion problem. If there are many documents are available and they will be in a different formats and in the variety formats, whenever the problem has overcome, that's what after documents have been converted to common format, they need to be stored in preparation for the indexing. After converting into the common format, they need to be stored for the preparation of the indexing, and document storage is required only for some applications. Document storage is required only for some applications. In desktop search, for example, if you consider in desktop search, for example, the documents are already stored in the file system. In the desktop search, for example, the documents are already stored in the file system and do not need to be copied elsewhere. So we know that in the desk search or in the desktop search, as part of it, the documents are already stored in the file system, do not need to be copied anywhere. As the crawling process runs, what is going to happen? It can send converted documents. It can send converted documents immediately to an indexing process. it can send converted documents immediately to the indexing process. How it is going to send? It is not storing the documents, but by not storing the intermediate converted documents. So if you try to understand here, as part of the desktop search, what is going to happen? As the crawler process runs, it can send converted documents immediately to the indexing process. So it will send immediately to the indexing process by not storing the intermediate converted documents. By not storing the intermediate converted documents. So there are other kinds of the search engines are there, need to store the document somewhere. In the desktop search, there is no necessity of storing the document somewhere, but some other search engines need to store the documents. And if you see, for the fast access, the document text is required in order to build a document snippet. Document snippet. What is meant by a snippet, and what is the purpose of the snippet? In order to access the document text very fastly. So whenever you are searching for any information on the Google, whenever you enter the text on the Google text box, what it is going to do is it is going to search the web in a scattered manner, and it is going to identify the links. Whenever you will be having the links, how you are going to open which link is suitable for you? So if you see, there are number of links, link 1 and link 2 and next link 3. There are number of links are there. This link is associated with some text, and this is also associated with some text. This is also associated with some text. If you see, only 1 or 2 lines of the textual information is able to view. By viewing that information or 1 or 2 lines of the information, you are going to access the text present in the entire link. So as part of the snippet, you are going to do the task here. In order to build the document snippet for each search result, these snippets of the text give the user an idea of that is inside the retrieved document without actually needing to click on link, without going to click on the link. So you just go with the browsable summary of the information, and accordingly you are going to access the data. So this is about the snippet. So here what we are trying to understand from this slide is, so as part of desktop search, there is no necessity of the storing documents, but the search engines, the remaining search engines may need to store the converted documents at one place as part of requirements for document storage system. Requirements for the document storage system. Up to now we have seen storing the documents and how you can, is there any necessity of storing the documents as part of the desktop search, and what is meant by a snippet and how the snippet will work, we come to know. And as part of the requirements for the document storage system, there are requirements are random access and compression and large files, and another one is the update. So these are all the requirements for the document storage system. If you see, this is the one of the point you have to understand and you need to remember about as part of the storing the documents, as we already familiar that with the databases and what is the importance of the databases. As part of it, using a database system, what is the purpose of using this database system here? Here, a relational database would be a good place to store document data. So we are talking about storing the document data, If you want to store the documents, what are the good places we will be having? So that's about relational database would be a good place to store document data. Web pages and makes it easy to update them later. So whatever the documents you want to maintain, so they will be stored, and whenever you want to make it modification, then it is a very easy task for the modification also whenever you store in the database. So here it is a very easy task, and it is an excellent place to store the documents. The database is an excellent place to store the documents. And if you see some more points about it, major search engines, major search engines use conventional relational databases. So major search engines use conventional relational databases to store documents, So one problem is sheer volume of document data. So if you observe here, there is one of the problem with this here, a sheer volume of the document data. So we know that from the starting class onwards we are discussing that web in regular days and every day so many documents are adding to the web. Whenever the documents are adding to the web, so web becomes very huge. So it is a very difficult task to find the documents from the web. So that is about the sheer volume of the document data, which can be OLM traditional database system. So this is the one of the point we already familiar. So this is about using the database, and the next one is random access. What is random access, and what is the importance of the random access whenever you store the documents? So we know that whenever you are maintaining the data in your document data store, it is very important to retrieve the data at any time in a randomized manner. So if it is only feasible, then only the justification will be done for the document data store. Here to retrieve documents quickly, if you want to retrieve the documents quickly, in order to compute a snippet for the search result, the document store needs to support the random access. So in order to generate the snippet for search result, the document data store needs to support the random access. As I already explained about the snippet and generation of the snippet, that must require what? Random access. And if we want a data store such that we can request the content of the document based on its URL. So if you want any data from the data store, if we want a data store such that we can request the content of the document based on its URL, using a hash function on the URL gives us number, we can use it to find the data, as we already know that hashing, so which is going to map key pair values. Whenever you use the hashing function, you are going to map with the key with the value, key pair value are going to map. Accordingly, you are going to identify the data. And here for small installations, the hash function can tell us which file contains the document. If you see, for the small installation, what the hash function is giving, which tells the file contains the document. For larger installations, the hash function tells us which server contains the document. So here, which file contains the document is about the small installations, and for the large installations, the hash function is telling that which server contains the document, So this is about information regarding to the small installations and the large installations. And once the document location has been narrowed down to a single file, so as part of identifying the files with the hashing or identifying the location, which will be the document here. Once the document location has been narrowed down to a single file, a B tree or sorted data structure can be used. Once it is narrated or once it is narrowed, so then obviously B tree or stored data structures can be used. So this is about the random access. As part of generating the snippet, for generating the result, in order to compute the snippet for a search result, the document data store need to support the random access. Next concept is about compression and the large files. As we know that as part of the storing the documents, if you are storing more number of documents, that occupies more storage. So whenever you are storing more number of documents, compression play will an important role. Then only you can store the data in a efficient manner. So the document data store system should make use of large files and compression. So for the document data store, it is going to use make use of large files and the compression. For example, if you see, for example, there are 10,000 words and those words require about 70k of disk space to store. This is far bigger than the average of the web page. This is far bigger than the average of the web page. But a modern hard disk can transfer 70k of the data in about million seconds, in the million seconds. However, the hard disk might require 10 milliseconds only, 10 milliseconds to seek that file in order to start reading, and this is why storing each document in its own file is not a very good idea. This is why the reason storing each document in its own file is not a very good idea. So if you see here, as part of the compression and the large files, the document storage system should make use of large files and compression. We are talking about whenever you will be having more number of words, how much space it is going to require, and it is going to compare with the average size of the web page. And whenever you consider the modern computer, how much time will it take to transfer that data. So this is about compression and the large files. Last one is update. What is update? So we know that whenever the document data has maintaining the documents in the document data store, it is mandatory to add new documents. So adding new documents and handling large volumes of the new and modified documents, and also adding new anchor text. As part of the update, handling large volumes of the new and modified documents, adding new anchor text. So this is about the update. Now we are going to learn about the concept big table, and we try to understand what is a big table and what is the purpose of the big table and what is the importance of the big table. Here, what is a big table? Big table, the word is itself having the clear meaning that it is big in the sense. Now we try to understand as per the definition. Big table is a distributed database system. It is the distributed database system. It is built for task of storing web pages. Why it is built? For the purpose of task of storing the web pages, the big table is built. Now a big table instance really a big table. For instance, the big table is really a big table. It can be over petabyte in size. It can be over petabyte in size, but each database contains only one table. Each database contains only one table. A big table is really a big table. It can over a petabyte in size, but each database contains only one table. Each database contains only one table. The table, whatever we are talking about, the table is split into small pieces called tablets. The table is split into small pieces. We can call them as the tablets. What we are calling them as tablets. So which are served by thousands of the machine. All the tablets are served by the thousands of the machines. And in relational databases, if you see in relational databases how these are different from. In relational databases, you will have encountered SQL. So what it is SQL? Structured query language. So here what the SQL allows? SQL allows the users to write complex and computationally expensive queries. The relational databases, you will have encountered SQL. So that's what structured query language. SQL allows users to write complex and computationally expensive queries. So if you are using the relational databases, there you can work out with the SQL, that is about the structured query languages, and you can write complex queries, and you can use expensive queries even in the relational databases. As part of this introduction for the big table, we are trying to understand that big table is a distributed database system. It is a distributed database system, and big table really is a big table. It is really a big table. So it can maintains the data in petabyte in the size. But each database contains only one table. How many tables it is consisting of? Only one table. Now the table is split into small pieces. We are calling them as the tablets. The table is split into the small pieces. We are calling them as the tablets, which are served by the machines, or thousands of the machines. So in relational databases, you will have encountered SQL. So we know that structured query language, where you can provide or where you can write so many queries if you want to retrieve any data from the databases, and you may also write some of the complex queries according to the need. And if you see some more details about the big table, this big table approach is quite different. It is a quite different approach. There is no query language. While we are working with the big table, and therefore no complex queries like in the relational databases. There are no complex queries, and it includes only row level transactions. So which could be considered rather simple by relational database standards. So here as part of this one, what you are going to understand, so there is no query language we are going to use, but the big table is going to use what type of transactions? Row level transactions it is going to use. And here whenever you observe the word, so really the big table is like a big table, and which will be converted or which will be split into the number of tablets which are served by the thousands of the machines, So here you come to find a new point. So this big table is using by the Google. It is the Google's document storage system. So the big table is the Google's document storage system, which is customized for storing and finding and updating the web pages. So the big table is the document storage system of the Google, and customized for storing, finding and updating the web pages. And it can also handle large collection sizes using the inexpensive computers. It can also handle large collection sizes using inexpensive computers. So here you are able to find the table, which can be divided into the number of tablets. Those tablets are served by the thousands of the machines. So here some more details about the big table. No query language you are using here. No complex queries to optimize. Only row level transactions we are going to use. As we know, tablets are stored in replicated file system that is accessible by all big table servers. So here you have to understand one more point. So we know that the big table is divided into the number of tablets. The tablets stored in the replicated file system that is accessible by all the big table servers. Whatever the tablets are there, they are all accessible by all the big table servers. Now, any changes to a big table, if for example, if you make any changes to the big table tablet or recorded to a transaction log, if any changes made to the big table tablet or recorded to the transaction log, the entire information will be maintained in the transaction log, which is also stored in the shared file system. And if any tablet server crashes, the server which consisting of the tablet will crash. What will be happen here? Another server can immediately read the tablet data from and transaction log from the file system and take over. So here you are able to understand tablets are stored in the replicated file system. Tablets are stored in the replicated file system that is accessible by all the Bigtable servers. Any changes to a Bigtable tablet are recorded to a transaction log, which also stored in the shared file system. That is also stored in the shared file system. In any tablet server crashes, if any tablet server crashes, another server can immediately read the tablet data and transaction log and the file system and take over. So it immediately take overs and immediately serves for that one. So this is about the Bigtable. So here, as part of this slide, what we are going to understand, there is no query language and no complex queries we are using. We are using only row level transactions. Here the tablets are stored in the replicated file system that is accessible by only the tablet servers. Any changes to the tablet servers, that will be recorded into the transaction log. And the table server, if any tablet server crashes, another server can immediately read the tablet and tablet data and a transaction log from the file system and take over. So this is the thing happened. And if you see the Bigtable, it is logically organized into the rows. So the Bigtable is logically organized into the rows. What the row consisting of? A row stores the data for a single web page. A row stores the data for a single web page. If you observe here, this is an example. For example, the information is maintaining about this web page www.example.com. So the entire information is maintained in the rows. So this web page is representing the one row of information. A row stores the data for a single web page. So this row is storing the one single web page information, as with some titles like here, if you observe, text, and another one title, and anchor other.com, anchor null.com. As part of the text, the document consisting of the text will be available here, and as part of the title, so this is what example site, whatever the example site you are using, that will be present. So that's about example. So that anchor will be maintained here, and these are all the different links associated with that example.com here. How it is from the there is a link to the other.com and there is a link to the null.com. Here this is about the Bigtable, how it is logically organized. It is logically organized into the rows. A row stores data for a single web page, and this row is representing about the single web page, that's about www.example.com. It is having the text field, so that consisting of the document text, and it is has title is here. This is representing the anchor text or example site, whatever it is. And here there is anchor other.com, anchor null.com. How many links it is associated with, from where it is getting the data. So those links are to be maintained, and some more columns will be added according to the need of the web pages. And here the combination of row key, a column key, and a timestamp point to a single cell in a row. So here a combination of a row key and a column key and timestamp point to a single cell in the row, single cell in the entire row. So this is about the Bigtable. Now we are going to discuss the next topic, that's about detecting duplicates. Detecting duplicates. What is detecting duplicates, and why these duplicates are generating? If you understand here, duplicate, the same page is repeated. The same page will be repeated in different places and different locations. If you try to understand duplicate, there is one more word near duplicate documents occur in many situations. Duplicate and near duplicate documents occur in the many situations. Making copies and creating new versions of the documents is the constant activity in the offices. So here the regular activity, as part of the regular activity of updating the web pages, adding new pages to the web and make modifications to the web, this is the regular task in the offices or anywhere if you are maintaining a personal. So that's what it will be maintained in continuous manner. And keeping track of this is an important part of information management. So keeping the entire documents is all about information management task, and this situation is more extreme in the web. This situation is more extreme in the web. In addition to the normal sources of duplication, plagiarism and spam are also common. In addition to the normal sources of the duplication, plagiarism and spam are also common. And here multiple URLs. So here multiple URLs to point to the same web page. This is the one more point you try to understand. So multiple URLs are pointing to the same web page. So it is also one of the problem, because whenever you are trying to get the information, the crawler is in dynamic situation, which is the document it has to identify for the retrieval purpose. Multiple URLs to point to the same web page, and mirror sites can cause crawler. So what are that? Mirror sites can cause crawler to generate large number of duplicate pages. So whenever it is going to work with multiple URLs to point to the same web page, and mirror sites can cause a crawler to generate large number of duplicate pages. So this is about detecting duplicates. As part of it, what we are trying to understand, it's a continuous activity, adding pages to the web, and whenever new pages are adding, obviously the redundant information will be increased in the web. And sometimes the plagiarism and spam are also the normal sources of the duplication. So in addition to the normal sources of the duplication, plagiarism and spam are also common. And multiple URLs to point to the same web page and mirror sites can cause crawler to generate large number of duplicate pages. Next, whenever you are in the process of duplicate detection, so we try to understand a duplicate page. So many duplicates are identified. How you are going to identify the duplicates? So exact duplicates detection is relatively easy. So exact duplicate, so in the sense there are two documents on the web. For example, you imagine if the two documents having the same format, the same text information is maintained in the two documents, then you can simply say exact duplicate detection, exact duplicate. So how you are going to detect, and is there any difficulty in finding the exact duplicate? When you think about one of the technique here, checksum technique is there, that is used for the purpose of detecting the duplicate. What is a checksum? We try to understand. A checksum is a value that computed based on content of the document. A checksum is computed based on the content of the document. For example, the document content consisting of some content, based on the content you are going to calculate the checksum. Now we will see how the checksum will be calculated. For example, the checksum for a file containing the text, the word you observe here, tropical fish. What is the word you are able to find? Tropical fish. This is the simple query you want to find about in the Google, and whenever you type tropical fish is the textual information present in the document. So how you are going to compute this as follows. Here you are going to work out and compute in the hexadecimal format. If you observe here, the sum of the bytes in the document file, the document consisting of the information tropical fish. Now you see here tropical, so this is TROPICAL, tropical, followed by fish, FISH, and you will be having a space. You will be having a space. Whenever you consider the hexadecimal value for the T, here that is a 54 and R 72, and like that you are going to consider for each and every character, and finally you are going to sum up this entire values. Accordingly you will get the sum 508. And in the same way, if you want to identify one more document consisting of the same text, then if you can calculate the checksum for the document also, if you get the sum as the 508, you can decide it is as an exact duplicate. So exact duplicate detection is relatively easy. Checksum is the one of the technique. How you are going to calculate the checksum? You are going to compute the checksum based on the content of the document. For example, if you can calculate the checksum for the tropical fish, this is consisting of 2 words, that is followed by the 1 space, and you are going to calculate the checksum value in the hexadecimal, and you are taking every value hexa value for the each and every character, and accordingly you are going to compute the sum of all the characters. You are going to get the 508 as the sum. 508 as the sum. So this is about the checksum calculation. And next, this is what a file containing the same characters in different order. For example, the word we have seen, tropical fish, and that will be a tropical fish. This is the one order which is present in the one document. For example, it is present like this: fish, tropical. Now you have the question, both are the same or not? Yes, obviously it is same. The file containing the same characters in different order would have the same checksum. Whenever you calculate the checksum for this one, both are same. Next, there are some more functions which are used for the checksum, duplicate detection, such as functions such as CRC. So it is simply abbreviated as CRC. We are simply calling it as a cyclic redundancy check, have been developed that consider the positions of the bytes. So this is the one of the function, so which is using or which has been developed that consider the positions of the bytes. Accordingly it is going to be processed. So this is also the one of the technique, cyclic redundancy check. Now up to now we have seen exact duplicate detection. So as part of the detecting the duplicates, we come to find that what is exact duplicate. So the content of one document will be presented same as in the other document. We can say there is an exact duplicate of the document. Now you need to identify the near duplicate documents. So because it is a very difficult task and it's one of the challenging task, so detection of the near duplicates is a very challenging task. Now you simply think about one question: are web pages with the same text or web pages with the same text context but different advertising or format near duplicates? So you will be having the same text and but with different advertising and formats of the duplicates or not? Think here, or web pages with same text content and but different advertising or format. Different advertising format. Here you try to understand what is a near duplicate. A near duplicate document is defined using a threshold. So we are going to use the threshold. Accordingly we are going to decide whether is it a near duplicate or not. So threshold value for some similarity measure between pairs of documents. So here a near duplicate document is defined using a threshold value for some similarity measure between pairs of the documents. If you see the example, you can understand. Try to understand a near duplicate document. A near duplicate document is defined using a threshold value for some similarity measure between a pair of pairs of the documents. So here a near duplicate document is defined using the threshold value for some similarity measure, between the pairs of the document. For example, you try to understand with this example, document. So document D1, you consider document D1 is a near duplicate of document D2. If you want to say document D1 is the near duplicate document of the document 2, if more than 90% of the words in the documents are the same, then only you can say it is a near duplicate document. For example, there is a document D1 and document D2. The words present in the document D1, if they are mapped with 90% of the words in the document D2, then we can say D1 is the near duplicate of the D2, or D2 is the near duplicate of the D1. Here document D1 is near duplicate of the document D2 if more than 90% of the words in the documents are same. More than 90% of the words need to be the same. So this is what near duplicate. So we can call and we can identify the near duplicate detection by using the threshold value for some similarity measure between the pairs of the documents. And if you see how we are going to detect the duplicates, as part of the detecting the near duplicates, there are two scenarios. There are two scenarios for near duplicate detection. One is such scenario, one is the search scenario where the goal is to find near duplicates of the given document D. So what is the goal? So goal is to find near duplicates of a given document D. This is like search problems. This is like all the search problems conceptually involving the comparison of query document to all other documents. So this is like the same general problems of all search problems, conceptually involves the comparison of the query document to all other documents. For a collection containing how many documents? N documents. For a collection containing the N documents, the number of comparisons required will be, obviously it is order of N, or big O of N. The number of comparisons required will be big O of N. The other scenario is discovery. The first scenario is the search scenario. As part of the search scenario, the goal is to find the near duplicates of the given document D. So this is like all the search problems which conceptually involve the comparison of the query document to all other documents, query document to all the other documents. So the number of comparisons required will be order of N. The other scenario is discovery, which involves finding all pairs of near duplicate documents, finding all pairs of near duplicate documents. So in the collection, this process requires how many comparisons? Order of N square. This process requires big O of N square comparisons. So there are two scenarios as part of the detecting near duplicates. One is search scenario and another one is the discovery scenario. First one is the search and another one is the discovery. How many comparisons it is going to take? Order of N. As part of the discovery scenario, how much time it requires, or how many comparisons it is going to take? Order of N square. Now as part of it, we will try to have some more knowledge on detecting duplicates. Word based representations of the documents have shown to be effective for identifying near duplicates in the search scenario. As part of the search scenario, what we are going to understand, so word based representations of the documents have been shown to be effective for identifying near duplicates. For identifying the near duplicates, word-based representation of the documents have been shown in the search scenario. The computational requirements of the discovery scenario have meant that new techniques have been developed for deriving compact representation of the documents. So the computational requirements of the discovery scenario have meant that new techniques have been developed for the deriving compact representation of the documents. So these compact representations are known to be fingerprints. So you see here, this is the one of the technique we are going to use as part of the detecting near duplicates. So the compact representation of the documents, the compact representation of the documents, we are simply calling it as a fingerprint. So here word-based representation of the documents have been shown, and the computational requirements of the discovery scenario have met the new techniques that have been developed for deriving compact representation of the documents. So that's what we are simply calling it as a fingerprints. Now we will have the discussion of the basic process of generating the fingerprints. The process of generating the fingerprints is as follows. Now we'll see step-by-step process, then we'll have the problem there. We'll try to understand as the step-by-step in detail. So what is the process we are going to follow? The process consisting of the first step as follows. The document is parsed into the words. As part of detecting the near duplicates, we are going to generate the fingerprints. So this is the basic process for generating the fingerprints. As part of that one, the first step includes the document is parsed into the words. The document consisting of the text, that entire text will be parsed into the words. Non-word content such as punctuations, HTML tags and additional white spaces is removed. As part of any non-word content such as punctuations, HTML and additional white spaces will be removed. And the second point is the words are grouped into continuous n-grams. The words are grouped into the continuous n-grams. So whenever you will be having the text will be considered as the continuous n-grams for some n value. So either maybe 1 gram or 2 gram or 3 gram, whatever it is. And these are usually overlapping sequences of the words, and these may be the overlapping sequences of the words, although some techniques may use non-sequencing, non-overlapping sequences. Some of the techniques they use non-overlapping sequences. So this is about the second. The first one is document is parsed into the words, and some of the non-content words such as punctuations, HTML, they will be removed, and the words are grouped into the continuous n-grams for some n value. So these are all usually overlapping sequences of the words, and although some techniques use overlapping sequences. And the third one, some of the n-grams are selected to represent the document. For representing the document, only some of the n-grams are selected. And the fourth point is the selected n-grams are hashed to improve retrieval efficiency and further reduce the size of the representation. Here, as part of it, your selected n-grams are hashed to improve the retrieval efficiency and further reduce the size of the representation. And the fifth point is about the hash values stored typically in an inverted index. All the hash values are stored as per the typically format of the inverted index. And the last step is documents are compared using the overlap of fingerprints. So these are all the different steps involved as part of basic process of generating the fingerprints. As you see, the first one, parsing into the words, the document is parsing into the words, and second one is grouped into the continuous n-grams, that may be the overlapping or non-overlapping, and some of the n-grams are selected for representing the entire document. From the one document, you are going to choose only few of the n-grams, and the selected n-grams are hashed to improve retrieval efficiency and further reduce the size of the representation. And the hash values are stored typically in the inverted index, and documents are compared using the overlap of fingerprints. So this is the process we are following. So if you see this one with the more example in a detailed manner, you try to understand as part of the identifying the near duplicate detection. Here we are showing this. So consider two near identical documents D1 and D2. You are going to consider the two documents D1 and D2. The fingerprints generated from n-grams selected randomly from the document D1. So whatever the fingerprints generated from the n-grams selected randomly from the document D1 are unlikely to have a high overlap with the fingerprints generated from a different set of n-grams selected randomly from the D2. So you are going to choose the two documents and accordingly you are going to process. A more effective technique uses pre-specified combinations of the characters and selects the n-grams that begin with those characters. So if you want more effectiveness, then it follows these steps: pre-specified combinations of the characters and selects n-grams that begin with those characters, And another popular technique called zero mod p. Zero mod p is to select all the n-grams whose hash value modulus is 0, where p is the parameter. So you are going to apply this process as part of this technique, and you are going to generate the fingerprints, and accordingly you are going to compare the two documents. Now if you see here, this is the example you are able to find. So the fingerprint example, the text, one document D1 consisting of this textual information like tropical fish include fish found in tropical environment around the world, including both freshwater and saltwater species. So this is the text present in the document D1. So that's what we are calling it as a original text. As part of the text processing, the words will be parsed. So the entire text will be parsed, and some of the punctuations and some of the words, they will be removed. So non-content words will be removed. And here the n-grams are selected. What are the n-grams here? The selected 3 n-grams. So 3 n-grams of overlapping. So what it is, so from this one, here you are going to select the first 3. Tropical fish include. So this is what tropical fish include. So these 3 words are identified as 3 n-grams, and next again you will be having that fish include fish. So these are the 3 terms you are going to choose: fish include fish, and next include fish found. Include fish found. Next, fish found in. Fish found in. In this way you are selecting as it is the 3 grams. So 3 grams you are selected, that's why you will be having 3 words: tropical fish include, again overlapping. That's why you started with the fish include fish, again include fish found, include fish found, like that. All the sequences are maintained as n-grams. So that's what 3 n-grams you will be maintained. As we already seen that we are going to compute the summation of the values what we calculated as checksum values. We will be calculating the checksum values, and we are going to identify the hash values for those values. You are going to generate the hash values. So here if you observe, so the values tropical fish include, you are going to calculate the checksum value. Accordingly you will be representing, and like that you will be having this word and you are representing, and you are going to choose only the few of the hash values from that formatted text or processed textual information. And among those hash values you are going to select the hash values using the 0 mod 4. You are going to apply the modulus of that particular value here. What is going to happen? 664. You will get the remainder as 0, and 492 you will get the remainder as 0, and another value 236, you will get the remainder as 0, and like that you are selected only the selected hash values using the 0 mod p, or these are the values only. And the same process you are going to apply for the another document, and finally you are going to compare those two fingerprints. We are going to discuss about another concept, sim hash. So this is also like the same fashion, but for improving the efficiency one can go with the sim hash. So here similarity comparisons using word based representations more effective at finding near duplicates, So here the problem is obviously efficiently you are going to find. So the as part of the near duplicate detection, so this sim hash function is going to play an important role, and this function is used by the Google also for finding similarity comparisons using word based representation, which is more effective at finding the near duplicates. And as part of the sim hash, it is going to combine the advantages of the word based similarity measures with the efficiency of finding fingerprints based on the hashing. It is going to combine, sim hash is going to combine the advantages of the word based similarity measures with the efficiency of fingerprints based on hashing, So here similarity of two pages as measured by cosine correlation. Here the similarity is measured by the cosine correlation measure is proportional to the number of bits that are same in the sim hash fingerprints. So here the similarity of two pages, whenever you are going with the comparison of the similarity of the two pages as measured by the cosine correlation measure is proportional to the number of bits, that are same in the sim hash fingerprints. And if you go for the procedure, this is the procedure for calculating the sim hash fingerprints is as follows. The process includes process the document into the set of features with associated weights. Here process the documents into the set of features with the associated weights. We will assume the simple case where the features are words weighted by their frequency. So according to the frequency of the words you are going to weight. And here the second point is indicating that generate hash value with b bits. You have to generate the hash value with the b bits for each word. For each and every word you have to generate the hash value. The hash value should be unique for each word. Each word. And in b-dimensional vector v, the third step, you are going to calculate the b-dimensional vector v, update the components of the vector by adding the weight for the word to every component of which the corresponding bit in the word's hash value is 1. So you are going to calculate and you are going to weigh the word for every component for which the corresponding bit the word's hash value is 1, and subtracting the weight if the value is 0. You have to add 1, the word's hash value is 1, and subtract if the weight if the value is 0. And the last step is, after all the words have been processed, generated b-bit fingerprint by setting the it to 1 if the ith component of the v is positive, or otherwise it will be 0. So these are the 4 steps we are going to follow as part of the sim hash function, and we will see in a more detailed manner with the same example as we discussed previously. So like this, this is the text as we have seen in the fingerprints also. Tropical fish include fish found. This is the text present in the document. This is the original text, we can simply call it as. And here in this step what you are doing is you are going to give the words with the weights. So for example, if you identify the topical, how many times the topical has repeated topical, and another one topical, here the frequency of that word is 2 times. And if you observe here fish, how many times the fish has occurred, fish is here, and fish here 2 times it is repeated. That's why you maintain with the frequency of that particular word. Fish is 2, and include, it is repeated in the 1 time. The next, found you can found at 1 position. So like that, the words associated with the weights. So the topical is repeated 2 times, fish is repeated 2 times, include 1 time, found, like that, every time it is repeated. And the next, you have to generate the 8-bit hash value for the each and every word. Your 8-bit hash value for the each and every word, like this. So you are going to generate the hash value for the topical, found, word, freshwater, like with the bits, so which is consisting of the 8-bit hash values. And the next, you have to form the vector V by summing the weights. How you are going to give the value by summing the weights, as I told you in the third point. So in the b-dimensional vector, we update the components of the vector by adding the weight for a word to every component for which the word corresponding bit in the word's hash value is 1, and subtracting the weight if the value is 0. So what you are going to do here is, here you will be having the first bit, if you observe, it is 0. How many times it has occurred? It is obviously you will be having a 0 value here. So the 0 is occurred 2. And now if you observe here, because the topical has repeated 2 times, now the value of the 0 is 2, and in the found you will be having the only 1 time, you will be having 1, and next 0 you will be having another 1, and one more 0 here, 1, and if you observe here, there is here is 1 and here is 0, here it is 1, and here for 0 you will be having 1. If you calculate, how many zeros? 2, 3, 4, 5, 6, 7. So you are having values 7 here, right? And next, if you observe the ones here, 1, and the fish has repeated 2 times, it is 3, 4, 5. So as you observe here, the values, how you are going to calculate here, the value of 0 is here, topical in this one, you will be having the 0, it is 2, the value is 2, and like this, if you can calculate 2, 3, 4, 5, 6, 7, so it is 7. And if you observe the ones, if you are having 1, it is fish has repeated 2 times, it is 2, 1 plus 2, 3, 4, 5, 6, 7, 8. So it is 8 minus 7. So you are getting the value 1. It is represented with the value 1. In the same way, if you observe here, the next bit also, here once if we can calculate, it is 2. So 1 is repeated 2 times, 2, and next 3, 4, 5. So 5 minus zeros, if we can consider 1, 2, 3, 4, 5, 6. So here it is 2, that's why it becomes changing. So once again we'll calculate 1, 2, 3, it is 2, 4, 5, 6, 7, 8, 9, 10. So it is minus 5, you are able to get minus 5, 5 minus 10, you are getting minus 5, and you can calculate 1 minus 1, 9, so vector V formed by the summing the weights. Next, if you observe here, if you are having any positive value, that will be replaced with the 1. If you are having the negative value, that will be replaced with the 0. So 1 1 minus 5 0, 9 1 minus 9 0, 3 1 1, 3 1 3 1. So 8-bit fingerprint formed from the V. So this is a 8-bit fingerprint formed from V. So this is the fingerprints you generated, and again in the same way you are going to take the document and you are going to calculate the another fingerprint. Again you are going to compare. So in this way you are going to calculate the near duplicate detection. As we already know about removing of noise, So here what the noise is indicating that when you observe the web page, in the web page only the portion of the web page is useful content, and the remaining portion of the web is having some of the advertisements, banners and each and everything. So here when you observe in the web page, the remaining portion other than the content, we are simply calling it as a noise. So many web pages contain text, links and pictures that are not directly related to the main content of the web page. So this is not related to the main content of the web page. That's what we are simply calling it as the noise. For example, the main content of the page, the story is outlined in the black. So whenever you observe this here, it is clearly depicting that this is the entire black portion. What we can observe that is the content of the main content of the page. So here the remaining what all the things, if you observe here, and these are all simply it is giving that it is as the noise. Here this is the only the part you can simply identify the main content of content block. This content block takes up less than 20% of the display area of the page, and the rest is made up of banners, what I already told you, advertisements, images, general navigation, links, services, etc. If you see some more details about it, this additional material is mostly what I told you, that noise. This additional material, we can simply understand that one as noise that could obviously negatively affect the ranking of the page. So whenever the ranking is going on, the noise will always shows the bad impact on the ranking process. The major component of representation of the page used in search engine is based on the word counts. So this is the one of the important point. As part of it you have to understand. So what is the major component of the representation of the web page used in the search engine? So it is based on what? So that's what word counts. Word counts will play an important role as part of the web page and the main content of the web page. There are some of the techniques have been developed to detect the content blocks in a web page. So some of the techniques are there. So for what purpose they are using? They are for the purpose of identifying the content blocks. So what is the main content of the web page? That is going to identify by few of the techniques. Non-content material is either ignored or reduced in importance in the indexing process. So we are talking about a web page consisting of both useful content and non-useful content. So the content is always playing an important role whenever a person is trying to retrieve the information whatever he wants to retrieve. But the non-content material is either ignored or reduced in importance in the indexing process. And as I already explained that this diagram is clearly depicting that the content blocks and remaining advertisements, banners and so on, they are all, we are simply calling them as the noise. Now if you see removing of the noise, as part of the removing of the noise, so we are trying to understand that a web page consisting of useful content and also the non-useful content. As part of the web page, if you want to identify that this is the useful content, how we are going to identify that this is the useful content? So here is one of the technique that is based on observation, that what is the observation we are going to make? There are less HTML tags in the text of the main content of the typical web page. When you see in the web page, the main content of the web page consisting of less number of tags, that consisting of the less HTML tags. This is the important point, you just keep it in your mind. So HTML tags. So whenever you observe that HTML tags in the text of the main content of the typical web page, then there is in the additional material. So once again I am repeating the same point, that some techniques are developed on the observation that there are less HTML tags in the text of the main content of the typical web page than there is in the additional material. So that's what additional material is, nothing but the noise. So that's what we are simply calling it as document slope curve. We are calling that one as the document slope curve. And whenever you go some details about the document slope curve, it is showing that the cumulative distribution of the tags. So what it is representing? Cumulative distribution of the tags in the example web page. From the figure, we will see in the figure here. So this is the cumulative distribution of the tags, depicting very clearly that what is the tag count on the y-axis and what is the token count here. You are able to observe accordingly the tags and the token counts are distributed here, and this is the text area representing as part of this one. So finding content blocks, if you observe here, this is the text area, and when you go with this point, you can understand in a very clear manner that document slope curve shows that cumulative distribution of the tags in the example web page from the figure as the function of total number of tokens. Total number of tokens, they are nothing but words or other non-tag strings. Words or the other non-tag strings in the page. And here the main text content of the page corresponds to the play 2. Here you can understand in the middle of the distribution, this flat area is relatively small. So as we observe that it's you are simply calling it as a play 2, and this is very small. This is the text area, very small. Here you are observing that cumulative distribution of the tags and finding the content blocks. That is about this one, and we will be having one more important technique that with that also we can also try to identify the noise. That one more technique is structure of the web page can also be used more directly to identify the content blocks in the page. So you also have the ability and the chance to identify the content blocks using the structure of the web page. Here these are the two main techniques. We are going to identify the contents as part of the less HTML tags are there. So with that also you can identify, and you can also use the structure of the web page can also be used more directly to identify the content blocks in the web page. To display a web page using a browser, so here if you understand this point in a clear way, we know that when you are going to display the web page, the browser, to display a web page using a browser, an HTML parser interprets the structure of the page specified using the tags. So obviously that is going to specify using the tags. The structure is the structure of the page is going to specify using the tags, and creates what it is going to create. It is going to create the document object model. Document object model. So that's what we are calling it as DOM. It is a DOM, document object model. So what it is going to do is as the structure of the web page can be used to directly identify the content blocks, and here the HTML parser interprets the structure of the page specified using the tags and contents and creates a document object model. That's what we can call it as a DOM. It seems to be like tree-like structure. DOM seems to be like tree-like structure represented by the DOM. The tree-like structure represented by the DOM can be used to identify the major components of the web page. If you see here in the diagram, you are able to identify. So this is the DOM representation, and you are very clearly going to identify what are the tags and what is the content of the web page. So here there are also some of the other approaches use DOM structure and visible features, right? So this is the another technique for identifying the noise in the web page. So with this we come to conclude that some of the techniques about how to store the documents. As part of storing the documents, one of the concept we discussed about the big table in a very detailed manner, and we discussed about detecting duplicates, how we are going to detect the duplicates, and we discussed the concepts about how to detect the near duplicates and what is the fingerprint process and how we are going to generate the fingerprints process, and we discussed about one of the function which is used by the Google, so sim hash function for identifying the near duplicate web pages, and finally, we discussed about the removing of the noise, and as part of it, we discussed that what is a noise and how we are going to identify the noise and how we are going to identify the useful content of the web page. So this is all about one of the part of the second unit. With this, I am concluding this session. Thank you one and all.